Sure about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
Who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all, and when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
5, 4, 3, 2, 1. Silence.
Hey, this is David D. Hilster. You are tuned in to Saturday Science Chats, and I'm David D. Hilster, and I'm glitching. I don't know if you guys are seeing me glitching. I don't know if it's my camera or what, but we have a great show today. Don't go away. We're going to be talking about, of course, the electric universe and the gravity, and we'll be talking with Dr. Ray Gallucci, and he's going to be presenting that to us. So stay tuned. Yeah, folks, I don't know. I feel like one of those, I don't know if this is my, do you guys see this glitching at all? How about you guys in the green room? But we have a great room today. Do you see me like glitching there? Do you guys see that? Oh man, I'm going to have to change my camera, but, or something's going on. I don't know what it is. That just happened. I'm just putting together my slides and stuff, but I'm going to change that for us. But let's just get right into it, my presentation, and then I will change that so it doesn't annoy the heck out of every week. We've got something weird going on. I hope you can hear me. Is that also good? Am I getting heard and stuff? Yes? Good? Volume good? Because I know sometimes, all right, sounds good. So I'm going to go ahead and get this, and maybe I'll just show the slides if I continue to glitch, because that is really annoying. So that's what I'll do for right now, and maybe I'll switch over. I do have another cam, but of course you've reached Saturday Science Chats, and we are sponsored by the John Chappell Natural Philosophy Society and Dissident Science Channel. So if you've tuned in from the Dissident Science Channel, I am David D. Hilster, of course, your host, and I want to thank everybody for subscribing. We are almost we're almost at 3,600 subscribers, and of course our natural philosophy, our natural John Chappell Natural Philosophy Society YouTube site is at $7.99. So if you haven't subscribed so we can get over that 800 mark today. But we've got a great show for today. But this is who is here and sponsoring this great show for today. And I want to thank each and every one of you, because without your support, of course, we would not be here, and not without only your support for those who help pay for this happening, but all those people who just come by, who subscribe. Make sure you hit the subscribe button. Click on the like button, because that gets more eyeballs onto what we're doing here. And this is the only place in the world where we do this, where we allow people who are critical thinkers to criticize mainstream. And of course, all the people we talk to and all the things we present are serious endeavors. So I want to appreciate and thank everyone who's participating and watching, who if you're even watching this on recording, it's very important to have you here, and your patronage of just being here. Of course, the CNPS's mission is an organization above all that promotes critical thinking without malice, to be an organization that supports, publishes, and promotes serious work outside mainstream science, to provide a forum for open debate about modern physics topics in physics, cosmology, philosophy, and mathematics, to provide a forum for presenting serious papers and theories without fear of censorship, to be run and controlled by its entirety by its entirety. I never read that right. I don't think I've gotten that right. To be run and controlled in its entirety by its paid membership, including the election of its directors by its members. Really important to us because we learned that the hard way. Just can't let anybody run this organization. We want to make sure they are looking out for us, the people who are critical thinkers. Of course, how can you participate? You can sign up on the Natural Philosophy website, or consider becoming a member. Memberships are annual and monthly. We do have some monthly members. I want to thank them. And of course, you can participate in our community discussions on our website or post news and happenings and share these videos to your friends. I'm sure everybody in the world wants to know why the Big Bang's wrong. Not everybody, but people like science for certain. Our websites, you can go visit them at naturalphilosophy.org, our online magazine, sciencewoke.org. If you're not so technically inclined and want to have some good reading, you can check that out, sciencewoke.org, and our Wikipedia at wiki.naturalphilosophy.org. That is a wiki with over 10,000 pages. And if you have your profile there, we can update it. It is closed. Why is it closed? Because Wikipedia is an open book and anybody can edit it. Of course, they don't allow anybody to put any ideas that are alternative or criticism, for instance, against relativity, even though we have experiments fly right in the face of relativity. They don't seem to care. So the only way we can keep our ability to put information about critical thinkers on a Wikipedia is to make our own, and it is closed. But if you want to help out and edit it, or you want your profile edited, you can contact us. We have a contact on that page, and just send it to us. One of the people, our members, just wanted their profile updated, and we did that for you. Oh, look at that. I've got software things popping up and don't pay attention there. Sorry about that. And we have our Chappelle University coming up, which uses LearnDash. If you want, you can we do accept memberships and donations because all these our websites all cost money now. It's subscription-based, everything. Monthly, we have subscriptions for MailChimp to send out our newsletter. We have subscription to our online publishing system, which is Overleaf, which we put all of our papers in. And we have 3 books coming out, folks. Yep, 3 books that the CMPS is going to be coming out with. One on ether, I think it's over 400 pages. One on, which is George Coyne's book on notfinity, or I think it's notfinity. He's going to get me for that, but it's on the consciousness. It's really amazing book that's going to be coming out. And of course, the particle model by my father and I, which is a model of the universe. And those things will be coming out this year via the CMPS. And our memberships, you can do them monthly. You can see a $5. Let me get my pointer up there. My laser pointer. There we go. Monthly from anywhere from $5 to $50 a month. And our basic membership, if you're a senior, you're on a fixed income once a year, $35, all the way up and up and up. And I appreciate it. We have our donors and our patrons, and I want to really thank our patrons this month. Dr. Cynthia Whitney, who's always a generous donator, a patron to our, they have Patreon now. It's like Patreon said more than patrons these days. Patreon is a website for patronage. And she's our CMPS chief scientist, PhD at MIT in relativity. It sort of all rhymes there. Nick Percival, I want to thank him so much. He's made a couple generous donations to our organization and has us really being able to function well, having these donations. My father, he gave another donation. I think that's for maybe keeping me away. I don't know what it is, but he and I are finishing up our book, and I want to thank him specifically for his generous donation. And actually some very, very sad news, very sad news. And I didn't know this, and I always give everybody sort of an update of our community, and I only found this out through the Sky Scholar, Pierre, who I'll be talking about a little bit later, but he had a video, and I was very shocked to see the video. You'll see it here later, on the passing of Dr. Edward Dowdy Jr. He was a retired NASA scientist. He said that gravity did not bend light. Einstein. And he said that the sun's corona, that should be apostrophe, the sun's corona or mass in space is what bends light, not space-time, which is nothing as many as we know. And he was very fluent in German. He read all of Einstein's work in the original German. And I was good friends with him for many, many years. In fact, he's in my documentary, Einstein Wrong, The Miracle Year. And he used to tell me about how he would read Einstein's work, and when they were translated, they were much more, how do you say, interpretive, and much more, how do you say, strong in their arguments, when Einstein was a little bit more, how do you say, doubtful, not doubtful, but more not so, this is my theory. He always mentioned that to me. So anyways, he was very fluent in German. He would speak German as like, whoa, this guy knows German. And he said that the Einstein's work were not translated well. So anyways, this is just a shock to me. He was not that old. He was retired. He was a member of the Laser Optics Physics Society, Physics and Electronics Engineering, retired from the NASA Goddard Space Flight Center in Greenbelt, Maryland. He was an independent researcher, and he came up with what he called the extinction shift principle. And unlike many emission theories, extinction shift principle applies both gravitation as well as electromagnetism and challenges both general and special relativities. He published his work in his book, Discourses and Mathematical Illustrations Pertaining to the Extinction Shift Principle under Electrodynamics of Galilean Transformations. And again, and if you haven't seen his work, this is a very simple graphic. It's from a while back. I know it looks like 1990-ish, pixelated in folks, but he had published this many years ago, and you can see the observation. There's no observed lensing. What happens is if you see down here, this around near the corona of the sun, there's a thin plasma rim, and in fact, you do see the stars in different positions. But outside of that, you don't. No one talks about this. I mean, Einstein's God. Einstein said that this should happen, but it doesn't. So you can see that there should be bending here according to relativity, and it isn't. If you want to check it out, there is a video that's done very nicely in memoriam of Edward. I think we're going to take a look at this. I was debating on whether to do this, but let's take a look. I think it's about 8 minutes long. That's the least we can do for a fellow colleague who is so important to our community. And this was done by the Sky Scholar, who I have some news about coming up. So let's take a look at this.
Today, it is with sadness that I wish to
room?
announce the passing of Dr. Edward Henry Dowdy on December 31st, 2020. Dr. Dowdy was born on November 13, 1943 in Washington, D.C. As an African-American physicist of that period, he was a trailblazer in American science. Dr. Dowdy received a B.S. degree in mathematics, electronics, technology, and physics from Hampton University in Virginia. He then completed a diploma in atomic physics from the University of Heidelberg in Germany, followed by a Ph.D. in laser physics at Howard University. He was employed as an engineer at NASA Goddard and was fluent in German and Spanish and had a working knowledge of academic French as well. In short, he was a brilliant and kind man who overcame tremendous adversity to leave a mark in science. Dr. Dowdy was a staunch opponent of general and special relativity. He gave numerous talks on the subject and even wrote a book on his extinction shift principle. The astrophysics community refused to accept his views due to the damage caused to their own models, instead of considering them scientifically. Dr. Dowdy was convinced that the sun had a dense atmosphere above the photosphere, and that is what caused the light bending claimed as proof of general relativity. He observed that the deflection of light was only seen near the limb of the sun instead of further from the surface, as general relativity would have predicted. This is how he inferred that the atmosphere above the sun was dense and became one of the first advocates of the new metallic hydrogen solar model. The birth of coronal helioseismology is now unwittingly proving Dr. Dowdy correct. Seismology cannot be done in a vacuum, as currently proposed in the standard model. It is only a matter of time before his reasoning on this question is widely recognized as true. Many of you will recall that Dr. Dowdy was invited to present some of his work here on Sky Scholar. He had driven from Washington to Columbus to film the clip, and I was honored to host him in our home. Dr. Dowdy was new to video production and found the process of being filmed and using a prompter to be a challenging experience. Though he felt he came off a little stiff, the final video explained his ideas well. If you have not seen Ed's video, go have a look. Truthfully, Ed was a wonderful human being. Much like Max Planck, he had a deep faith and love of science. No one could move him from the position he knew to be true. It is my hope that his ideas live on here and elsewhere and are finally given proper recognition. I pray our viewers will keep Ed in their thoughts and work to help ensure that his contributions are remembered for a long time to come.
Yeah, I mean that's so sad. Again, I really appreciate that he was able to do a video like that. I'm going to take a real quick thing here and see if I can switch my camera here to the other camera and see if that's going to be better. Because it's sort of, I don't like looking at myself, but I think we're going to be better. So there we go. Now I can do this. There we go. Not a wide angle. But anyways, I want to thank Pierre for doing that video. That was quite nice. And I have some news about him coming up.
It is with sad.
Okay. Shh, quiet. All right. We do have some other videos, and I like to keep that people up to date. You can go to naturalphilosophy.org and see these. This one's on repulsive gravity. We've been talking about gravity, so check it out. No, it's not attraction, but it is really, really interesting. Nick Percival and my father both watch this, and they both recommend it. And if they recommend it, you have to watch it. I'm just kidding. Yeah, we're so important, everybody. That's why we got millions of viewers. Someday you watch. But anyways, check out those. And if you don't know where to go and see these, go to naturalphilosophy.org and take a look. I'm going to go to the next one. This is another good one. These are our videos that I post on our Natural Philosophy feed, our activity feed, which is very much like Facebook. Check it out. Register. It's great conversations, a lot of discussions going on there. And this is Richard Guy, Receding Season Earth Expansion. Believe it or not, the Romans, if you watch that, I guess, my dad told me this in this video. He says, the Romans built roads right by the sea. They are now like 10 kilometers inland. So one of the things this guy was, when he was very young, was interested in this, and then he found out about expanding Earth and expanding Earth. And I know that the Electric Universes people are now on board with that. We're in the beginning, but play What's Coming bumper, Dave. All right, I will do that. Actually, we have more coming. Believe it or not, we got a lot of people contacting me. I even had one person that went over to my dad. Hey, Dad, someone called this an extraordinary program in an email. I think they were trying to butter me up so they could be on the program. But hey, it's great. I mean, I think, again, this format and what we're doing is absolutely fantastic. We're talking with the best minds in the world outside of science. And, what do we have combined? Maybe 4,000 subscribers. Come on, folks. Let people know about this. This is fantastic. We support everybody who's trying out to be a dissident. Yeah, we have tryouts. No, we don't have tryouts. I just can't speak. But what we have is the ability to support all the critical thinkers. We're not looking to endorse people. We're looking to bring in what we think are really great critical thinkers with great ideas. And of course, one of them is Jack Kirkendall, who's agreed to allow us to put his math into our book in the sense of the math system, because we believe in it for physics, because it doesn't have negative numbers. It is a great system. And if you missed it, you can go February 6th and check that out. But he is coming. It's not coming February 6th. That's already in the past. This is not time travel, folks. But it's a symmetry math. Again, if you've checked it out, check out the his presentation. It was absolutely amazing. It'll blow your mind. Yeah, the real number system sucks. This whole idea that the square root of -1 is a good idea, it isn't. He says that there's over a dozen meanings for the minus sign in mathematics. That's not good. Anyways, he's coming back. He's going to actually be back next week, so you don't want to miss that. Then coming in, no, not coming in February. These are old slides, but coming in March, I have one that says coming in March. I put these together in the morning, and I've got lots of things to do. So he's coming in March. If you haven't read or know about Dr. Alexander Unsker, the Higgs fake, read the Higgs fake, read the Higgs fake, read the Higgs flake. I don't know how many times I have to tell you that. So if you believe in all these new particles, even quarks, neutrinos, the Higgs boson, please read the Higgs fake, because after you read the Higgs fake, you're not going to believe any of them, because the science behind the way they do this stuff is absolutely horrific. So please read that. He also has other the bankrupting physics and Einstein's lost keys. He's a doctor in science, I think in physics, and he's a journalist, author, and researcher. Also coming is Stephen Bryant, this disruptive, rewriting the rules of physics, the demise of relativity. You can read a little bit about that. If you haven't got that book, check it out. It's really great. He's going to be coming on. Love Steve. He's a really great speaker, very engaging, and have him on. And yes, I got a phone call out of the blue, and who was it? It was Pierre-Marie Robitaille. And I don't know how to pronounce his last name, but Pierre. He is an absolute amazing guy. He's the Sky Scholar. And I know there are a lot of people watching today know this guy and subscribe to this guy. He's got over 30,000 subscribers. And he may be coming on the program. I told him, he says, we are the program in critical thinking on the planet, and you're a celebrity. This is our small world, In the real world, it's like you've got to have 2-3 million subscribers to be a really amazing channel, and you have to win the Nobel Prize. But these people should be winning Nobel Prizes. His work on the sun is absolutely phenomenal, and on the Hubble. What is it? What's the? I can't remember now. I'm going blank on it. But he also works on different things. Look him up. You can look him up on our Wikipedia, wiki.naturalphilosophy.org. Take a look at it. He also promotes people like the now passed great Dr. Edward Dowdy. And also he has Stephen Crothers. That's right. He will. If you think the Big Bang's okay, I'm sorry, Fred. The Big Bang isn't okay. So anyways, hopefully he'll be coming on. So if you have his email, you can contact him, say, hey, go on Dave D. Hilster's and the CNPS's program. Okay, I put my name in front of it because nobody else wants to. So no, I'm kidding. Anyways, that's going to be absolutely fantastic. I love the guy's work. Check it out. In fact, I think he went to Europe, and he has an interview with he and Dr. Alexander Unsker talked. See, they're all together. I said, hey, you went on you talked to Dr. Alexander Unsker, you can talk to me. Well, I'm the guy that cuts the lawn, and Alexander Unsker is the scientist and the tyrer. I'm just a normal dude. So as my friend Alexander Unsker says, keep working on your passion. If it's the electric universe, work on it. If it's ether, work on it. If it's particle model, work on it. If it's a different model, work on it. Just keep working on your passion, and that's most important. We support you 100%, because if we don't support each other, even if we disagree, we're never. People go, nobody pays attention to my work. Well, do you pay attention to other people's work? Because if you don't, then you're violating your own rules of wanting people to pay attention to your work. Get it? It's easy to understand. So let's all support each other, saying, hey, you're an etherist. I don't believe ether's right. That's me, for instance, but I support their theories. They're really good. They're really good models out there. So Electric Universe has a lot of great science going on. I'm not an Electric Universe person. I believe in a different model, but a lot of what the Electric Universe is saying, I agree with 100%. Well, you don't have to agree 1,000%, 100% with any of these, but support them, please. Support them, please. And of course, we are talking today, gravity and electric universe, and play today's bumper. You know, since I put them in the slides, I've not forgotten them because I make these things and then I don't play them. So what's that? So this is today's bumper. And I see Ray, he's in the wings in our green room waiting. He looks like Kilroy. I can't even see his mouth, but yeah, he looks, you know, I don't know if you're old enough, Kilroy, you know, that looked over the fence here. Here we go. This is today. Yes, sir. Yes, sir. Let me tell you a little bit about Ray and where we are. We've been talking about gravity. We've already talked about ether and gravity. Now we're going to talk about electric gravity. We haven't talked really about space-time. I don't know if we ever want to space-time. I think everybody here pretty much agrees that one's cost. And we haven't talked about the particle models for gravity, like my father and I have. We have electric parts and particle parts and gravity parts, etc. But today we're going to be talking about electrical part of gravity. It's part of our series in 2021 about gravity. It's a heavy subject. Sorry, it's not even good. Dr. Raymond Gallucci, who he is, he's a nuclear engineer, researcher, and author. He's an American nuclear scientist who contributes papers regularly to the CMPS proceedings, attending their annual conferences. We're going to have one this year. It's going to be relative. Look what I was going to say. Instead of virtual, I said relative. No, it's not going to be. It's going to be virtual. And Gallucci believes black holes, Big Bang, and many other correct popular theories in cosmology to be incorrect. And what's most amazing about him, this is very important for you. So if you haven't seen him, we're going to be looking at one of his presentations today. Absolutely great presentation. He is a person that doesn't have his own theory, but he likes to put to test other people's ideas and theories. So that's what we're going to be seeing today. This is him at one of our conferences. Yes, he is the most prolific contributor to the CMPS in the last 5 years. And if you haven't read his work, then you can go online onto Amazon and get it. The Renegade Physicist by Raymond Gallucci. And if you're one who worships at the altar of Einstein's relativity, Big Bang cosmology, then this book will not be of interest. I love it. I mean, at that point, you pretty much just throw away all the people who aren't critical thinkers right at that moment. Great marketing scheme. You know, who would have known an engineer could do some marketing? But you can read more about it. He has a collection of 44 papers, mostly published in non-mainstream. He's very honest about that. And they are divided into 6 topical areas. Very well worth it. Very cheap. He doesn't put it very expensive because he wants people to actually read it. I think, that's it? Oh, no. We're here, but I'm going to bring him on before we do that. Let me get this away. And please sit up, because if I introduce him right now, he looks like Kilroy. Get your face. There you go. Don't be shy. No, turn your camera down. I'm like because I did a movie, I think I'm a director now. And there we go. Oh my gosh, it looks good. So now I don't feel so bad. I'm going to bring him on. He looks like a scientist. Here we go. Adding him to. Hey, Ray, how are you?
Good morning. Doing well.
Oh yeah, you look great. I mean, you look. I like the scientist look. You don't look like Einstein, and that's the most important thing. Because if you notice, like, what's his Michio Kaku or whatever his name?
Oh, Michio Kaku.
Yeah. Yeah. I never get his name.
He's not that bad because I seen him on Ancient. He's on a lot of what you would consider dissident programs. He's not that.
Yeah, no, he is. Of all the people, he is. I mean, when he was asked if Einstein could be wrong, he didn't laugh. Neil deGrasse Tyson just laughed and said it's been proven 1,000 times. You know, that's just not.
You can't follow him.
Yeah, exactly. But
Michio's okay.
Yeah, he is. He is actually okay. And so, why don't you tell us a little bit about this talk we're going to be looking at? I think you presented this on the EU YouTube channel, correct? And it's got a lot of views.
This is the Space News presentation, right?
Right.
Yeah, electric unit. I presented this about a year ago. And I remember the first two, it was back then, it was NPA, Natural Philosophy Alliance conferences in 2011 and 2013, the first two that I attended. And those were joint conferences with the Electric Universe people, and I had never heard of them or any of their theories. And of course, I became intrigued. They had a lot of, they basically had two different prongs of interest. One was related to a lot of it going back into mythology, etc., where there were theories that Saturn was once a star and the alignment of the planets was quite different. But then on the other aspect, more along the Wall-Thornhill area, was a lot of the the theories as far as the sun being a plasma discharge, and a lot of the work of Dr. David Scott, and it was along more of this aspect of Electric Universe that I found more appealing. And I remember their president, it was Wall Thornhill's presentation on his theory, or the EU theory, of what is gravity. And basically, his theory was that it's an electromagnetic phenomenon, and it's caused by the formation of dipoles in atoms due to their proximity. And he had a very interesting presentation, and you can see that on the Electric Universe channel. And so I got a little interested in that, and I tried to do a simple examination of it by simplifying it to a static problem where I could handle the physics and math and look at it from just like Coulombic forces, etc., for three adjacent hydrogen atoms. And my goal there was just to see what would be the traditional classical effect of Coulombic forces on one of the atoms, to see if the formation of a dipole made sense. And that's basically what my presentation is about. Now, I don't get into electron clouds. I don't have the electrons moving around. I don't have any quantum theory. Again, it's a very simple approach just to examine plausibility to see whether or not there might be some possible truth to the Electric Universe theory of gravity.
Yeah, that was great. I did see this, and I saw that you had a series on there, and there are quite a lot of views. And I know I can see that our attendance today live, there's I'm sure quite a number of people. I announced this on some of the Electric Universe Facebook pages, which has it's got a big following. It really does have a big following. I mean, I watched them go over 100,000. They're on their way to 200,000 subscribers. That's just phenomenally. So without further ado, I'm going to take you down here, and we're going to watch his presentation in full. And again, if you're in the green room, please give me a thumbs up that everything is working. I resolved the one of the things we're getting a lot of comments a lot of times is our levels of our audio and all that. So please put your comments there, and let's watch this video. And here we go.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The Electric Universe theory proposes that electromagnetism, not gravity, is the predominant organizational force in the cosmos. In the space age, countless discoveries, from the networks of filaments connecting objects across vast cosmic distances, to the pervasive magnetism seen at all scales in the universe, to the structure and motions of galaxies themselves, are all better explained from an electrical rather than gravity-centric viewpoint. However, this is not to say that the Electric Universe denies gravity's existence. For more than 40 years, the leading proponent of the Electric Universe, physicist Wall Thornhill, has worked on an explanation for gravity that actually links gravity and electromagnetism. In recent years, retired nuclear engineer Dr. Raymond Gallucci discovered Thornhill's electrical theory of gravity. Today, Dr. Gallucci presents the simple mathematical modeling he has performed to test the theory's plausibility.
I first came across EU theory back in 2011, and I don't recall if I first came across the electromagnetic gravity theory at one of the early conferences or via the website, but it doesn't really matter because I did come across it, Wal Thornhill's theory. I know he's presented it at the conferences and there's some videos of it. And given that there's 39 orders of magnitude between the strengths of electromagnetic and gravitational forces, it makes one wonder just what's going on. Plus the fact that electromagnetism can have a repulsive aspect as well, at least with Coulombic forces. So EU theory has asked the question, is it even conceivable that these two could somehow be related given such vast differences in their strengths? And the EU theory says yes. And so my background is a nuclear engineer. I'm not up too much on electromagnetism. So what I try to do with my papers is I tend to take other people's theories and I try to look at them for plausibility from an independent aspect. And so I figured that maybe this electromagnetic gravity is something I could tackle without having too much electrical background. So I went ahead and gave it a try. And I'll just read. This is from the holoscience.com website, Electric Gravity and Electric Universe. This is Wall's theory that gravity is due to radially oriented electrostatic dipoles inside Earth's protons, neutrons, and electrons. The force between any two aligned electrostatic dipoles varies inversely as the fourth power of the distance between them, and the combined force of similarly aligned electrostatic dipoles over a given surface is squared. The result is that the dipole-dipole force, which varies inversely as the fourth power between collinear dipoles, becomes the familiar inverse square of gravity for extended bodies. The gravitational and inertial response of matter can be seen to be due to an identical cause. The puzzling extreme weakness of gravity, and again, you're talking about 10 to the 39th power with electromagnetism or electrostatic force, is a measure of the minute distortion of subatomic particles in a gravitational field. And there's that nice diagram on the Holoscience or the Thunderbolts website that shows the three atoms in a vertical line and the slight off center of the charges of the protons and electrons, which EU theory alleges may be what gives rise to gravitation. Continuing with the EU theory on gravity, the 2,000-fold difference in mass of the proton and neutron in the nucleus versus that of the electron means that gravity will maintain charge polarization by offsetting the nucleus within each atom. And that's what's shown on the diagram. The mass of a body is an electrical variable, just like a proton in a particle accelerator. Therefore, the so-called gravitational constant, the g, with the peculiar dimensions of length cubed over mass times time squared, is a variable. That's why g is so difficult to pin down. And so that's just the background, which I guess anybody can find if they look under the electromagnetic gravity slides from Wal Thornhill. So what I tried to do, and it's shown in my paper, is I took the diagram from the electric universe theory of the three atoms. I took three hydrogen atoms for simplicity, and they're shown vertically on the EU website. I turned them horizontal. So I spaced them. I said three hydrogen atoms of radius r are aligned and equally spaced. The distance of 3r, r being the radius of the hydrogen atom, from center to center. We are interested in the distortion on the leftmost, which is the reference atom, due to its two neighbors. That is the net electrical force from each neighbor's proton, which is shown in the diagram as a gray circle, and the electron, which is shown as a dotted orbit. This is a classical representation of the atom. It's not a quantum representation. It's the Bohr atom with the electron orbiting. On average, the electron spends half its time in each hemisphere as it's going around in its orbit, in each of the neighbors, with the average position being along the alignment. And it turns out, if you do the math, the distance is 0.6366 r. So it's about almost 2/3 along the radius is the average position when it's in each of these hemispheres. And again, that can be seen on the diagram. Both the reference proton and electron will be subject to 6 forces: attractive when of opposite charge, repulsive when of the same charge. And that's because on the diagram, you'll see that relative to the reference atom, I have 2 atoms that are to the right of it. And each of those atoms has a proton, so that's two of the other forces. And then I've shown the average position of the electron in each hemisphere on those two atoms, and that comprises the other four positions. So I'm basically looking, I've taken what's a dynamic situation, I've tried to make it static so I could do some calcs. And I'm showing the reference atom, its electron, its proton being affected by basically six other charges, two of those being the stationary protons, the other four being the average position of the rotating electrons in each hemisphere on the other two atoms. The vector sum of these six forces will constitute the net electrical force on the reference proton and electron and indicate the degree of distortion imposed on the reference atom from its two neighbors. Remember that the EU theory is that there is a distortion due to the presence of other atoms, and this very slight distortion is what accounts for the gravitational force. Based on symmetry, the center atom should experience no distortion. That's the atom with the hydrogen atom in the middle. It has one on each side of it, so it's a symmetric position. So it wouldn't experience anything in this diagram that I'm showing. The rightmost atom should experience the exact opposite distortion to the reference atom. My reference atom is the one on the far left, and so the one on the far left and the one on the far right, I could analyze for either one of them being affected by the other two. And just for convenience, I worked on the left atom. So I did some trigonometry, and I came up with this formula that shows the distance between the electron's position and the reference electron position and the position of each of the other average positions of the electrons in the other atoms. And after I worked out that formula, and I had to do some calculations, and I set up a spreadsheet to analyze each of 360 degrees as the electron on the reference atom goes around in its orbit. At each of those 360 degree positions, I calculated the distance between it and the other reference electrons and protons. And knowing those distances, I was then able to calculate the net force on that electron from each of those positions and do an averaging over time in order to get the average net force on that electron to show whether or not there would be the distortion that is part of the electric universe theory. And I have a graph that shows this in the paper. After one performs all the calculations to derive the net force on the reference electron, which is a vector, so direction must also be addressed. Fortunately, I'm dealing in 2 dimensions, not 3 dimensions. I'm not looking at an electron cloud. I'm looking at an electron in a circular orbit. Again, the classical view. The results can be plotted as shown. They are presented in terms of the closer hemisphere to the middle atom, and the far sides, the farther hemisphere from the middle atom, for the electron as it circles the proton. To simplify the presentation, I scaled the results by 4 pi epsilon 0 over q squared, which I put everything relative to that, and I set the radius of the atom equal to 1 for the purposes of scaling so I could do my diagrams. And what I have here on the figure on the paper, it shows that when theta equals 0, when the electron is in the same line as the 3 protons from its reference atom and the other 2 atoms, we have the reference electron at both the farthest and nearest positions to the neighborhood atoms. Here, the difference between the net forces, which is shown as a solid line in the diagram, is maximum, and it's labeled there as the maximum location. This is also the only position where the directions of the 2 force vectors are exactly aligned. This difference decreases as the electron positions get closer until they are equal at theta equals 90 degrees, where the near and far side positions coincide. So on my diagram, if you put the electron that's orbiting the reference proton at the top or the bottom, it's the same distance from the other 6 electron positions and the 2 protons and the neighborhood atoms. I observed that the difference between the net force peaks at around theta equals 45 degrees. So when the reference electron is about 45 degrees, either upwards or downwards from its nearest position to the other atoms, that's when the difference between the net force directions is peak. Having said all this and shown the diagrams again, which one needs to look at to really understand this. The key observation is that over the entire orbit of the reference electron, the net force from the neighboring atoms is repulsive. This means that the electrons in the neighboring atoms push more on the reference electron than the protons in the neighboring atoms pull. So you don't have symmetric forces between pulling by the protons, the attractive forces between proton and electron, and the repulsive force between the other electrons and the reference electron. There is a difference between those two forces, and the net force is a repulsion. As a result, there should be some displacement of the electron orbit and distortion given the asymmetry between the forces acting on the two hemispheres away from the neighboring atoms, and opposite to the direction in which the reference proton is pulled. The figure, again shown in the paper, this illustrates the effect on the orbit of the reference electron. And what's shown in that figure, where I had to scale it up because the distortion is it's on the order of like 0.01%. So I scaled it up a little so you could see it. It shows that the circular orbit of the electron and the reference proton actually gets pushed inward a little bit on the right side, which is the side nearest to the other two atoms. So it's not a pure circle, it's a slightly flattened circle. Now, I also looked at the effect on the reference proton, because now we see that according to EU theory, we're talking about a dipole being set up. So the electron's been displaced slightly in its orbit. Does the proton also get displaced a little bit? The net force from its neighbor atoms for the proton on the scaled metric is a pull, an attraction of about 0.02, scaling to a value of 1. This exceeds the push on the reference electron over the entire far side of its orbit, but remains less than that over most of the near side of its orbit, with the amount by which the exceedance over most of the near side exceeds that over the far side being greater. So while the reference electron has its orbit pushed away from the neighbor atoms, the reference proton actually experiences a pull towards them. So our reference, as shown in the diagram that Wall presents, clearly not only do we have the reference electron being pushed away slightly from its other atoms, we have the proton on the reference atom being pulled a little bit. So we have kind of a double distortion in the setting up of the dipole that might account for the gravitational force due to electromagnetism. And so it's not only the distortion of the electron, but there's a slight distortion of the proton position, not as much because the proton is more massive. The reference hydrogen atom no longer is symmetric with a circular electron orbit about a centered proton. That thereby suggests the creation of an electric dipole, which is what was postulated by electric universe theory. So I do have a caveat that I put in here, and the caveat basically is in my calculation, this is a very simple model. I assume that the electron's orbital speed is that of light. There are some references that show electron orbital speed dropping might be maybe 10% or 1% that of light. I don't think anybody really knows how fast the electron goes. Certainly not in a quantum mechanical model. I mean, it's just a probability state anyway. So this is again talking about the Bohr type of atom where you have the classical. But if the electron slows down enough, like down to 1% that of light, then the distortion would be off scale in my model. So my simple model is valid so long as the speed of the electron is very close to that of light. So after injecting some mathematics, and this is my conclusion, greatly simplified, I have to admit, into EU theory that gravity can be attributed to an electromagnetic effect, although almost inconceivably smaller, again, we're talking about that 10 to the 39th, due to the distortion of atoms by their neighbors into electric dipoles, the possibility of an electromagnetically induced distortion to create an atomic dipole appears plausible. So again, my goal was to take the EU theory and try to do an independent math physics calculation to see if it was at least plausible. And it turns out that it certainly is plausible. And that's what I was trying to show in my paper. And I also was able to show that the ratio of the displacements between the electron and proton are on the orbit of about 1 to 10,000. So again, you've got much more distortion on the electron than the proton, but the distortion is about 1% of the Bohr radius itself. So the electron doesn't get distorted very much, and the proton is about a factor of 10,000 smaller. So we do have this very, very small distortion that is postulated, but it may be enough to actually give rise to the gravitational force being the result of electromagnetic, electrostatic forces in atoms themselves.
Okay, so thank you very much for the presentation. So you made that
A lot
about
easier when it's already recorded.
well, you didn't miss a beat. I mean, it wasn't like me, with bad cameras and all kinds of flops. But anyways, I had a couple questions, and we're going to ask, have some questions. In your calculations, you were, I noticed one big sort of important assumption was that there were three atoms together, and
Yeah.
they were in a line. So you were,
Right.
and then the gravity was in that line. So my question is, well, that's
Well, the
ideal
gravity
because,
isn't necessarily in that line. The gravity results from the formation of a dipole. I'm not sure. I'm not an expert, electromagnetic expert, but the dipole, the direction of the force from the dipole may not be in the same line as those three atoms. Those three atoms were just a representation that from Wall Thornhill's presentation.
okay, yeah, because
I'm not showing gravity along that line. I was just trying to show that it was possible to form dipoles.
Yeah,
Electric
because
universe theory is that gravity arises from the dipoles themselves. So the formation of a dipole is not the gravitation, but it's the gravitation is the result of having formed dipoles.
right. Yeah, and because when I see that diagram where the three are in a line, and then there's a line that shows the gravitational force. When you were calculating, one of the questions I have also, when you were calculating the force differences, right, which turn out to be gravity, am I getting that right in general?
Well, no, all the force differences are Coulombic. I did everything. I didn't do any gravitational calculations
Oh,
whatsoever.
no, I know, but I mean gravity being Coulombic, meaning Coulomb's law,
Well, the
electrical force.
distortion is caused by the Coulombic forces, and EU theory is that as a result of the formation of dipoles, that the Coulombic force from a dipole is what manifests as gravity. That's EU theory.
Right. That the force is the Coulomb's law, the force from Coulomb's law.
Yeah, the 1 over r squared similarity.
But again, it comes from a very, I guess what I'm just trying to understand for the sort of a lot of lay people, is that when the atoms are close together, the orbits or clouds, whatever you want to say, are distorted in a very small sense, and that's one of the reasons the gravity is a small force compared to like Coulomb's. Is that correct?
That's what I take from Wall Thornhill's presentations. Again, I couldn't show anything approaching 10. My distortion was on the order of 1% of the Bohr radius. Now, how strong a dipole that makes, and what because the dipole, apparently the attraction or the force from a dipole, from what Wall says, is on the inverse fourth power of r. And what he was saying is that when you combine all of these, it manifests as sort of the r squared dependence. So I don't think anybody, certainly not me, and I haven't seen anything in electric universe theory where they have mathematically attempted to show the 10 to the 39th difference. Okay.
And I guess one of the curious things I'm trying to figure out in my head with the model is then when you have a lot of different atoms, right, together, not just in a line.
Right.
Do you have some feel about how that would work compared
Well,
to
that
just
might
the
be,
three?
maybe that's the reason why you get such a small force, because they probably, how many of them cancel each other out, etc. And if you have a glob of all these hydrogen atoms together, what's the net force? I mean, obviously, if you pretend the sun is pure hydrogen, then what you would assume is that if electric universe theory is correct and all these hydrogen atoms, some zillions of them together, somehow all these dipole forces manifest as the known force of gravity, which is radially inward. And so it would be kind of like a mesh effect or something. How many cancel out, and why the net effect would be something radially inward and attractive, I don't know. But that would be what one would probably conclude from this, is that there's all these all these hydrogen atoms form all these dipoles, and by the time you get so many of them in something like a sun, then for some reason the alignment comes out to be radial to satisfy Newton's law. And to the extent that space-time is just a model of gravity, it also would satisfy space-time relativity.
Okay. Now, another question I have, and I know
Walt Thornhill's the guy to explain that. I'm just guessing.
Right. Yeah, I'm just curious myself, because the other question I have, and again, it's not criticism, just questions, and that's why maybe I don't even know if Walt's addressed these questions. But how do you see, from the calculations you made, not anything else, but the calculations you made, how would you see how far this goes? One of the things I'm not seeing, for instance, is how far, because gravity obviously has an immense reach, right? It has an immense reach, and Coulomb's force doesn't seem to have that immense reach. So if it's the Coulomb's force that's doing it, how is it that we have gravity that's affected at these immense distances?
That I don't know. It's the only. I mean, electric universe people are going to say that all the bodies are charged, so that with the Coulombic force being 10 to the 39th time stronger, that even after it's reduced by this dipole formation, etc., it's still strong enough to be manifested as gravity. So that's, but again, the electric universe people believe that the Earth, the Sun, the Moon, all these bodies have a net charge on them. So that's why there's that's what's somehow that enables them to be attractive.
Okay, so I think what you're saying, and again, I don't know if anybody in the green room is an electric universe person who maybe could answer it, then it sounds like gravitation in the EU between like heavenly bodies or celestial bodies, maybe a different type of process than what you were examining?
Again, like I said,
okay,
mine is such as just that I took such a small aspect of it, was just to look to see if dipole formation made sense.
Right.
And there's a growing trend with the electric universe people to try to put more math into their theories. A lot of their theories are more on the qualitative side.
Right.
And there's I know one guy, Roger Poisson, who I saw at the 2017 conference. He was doing some astrophysics calculations and some models to try to show how there might be attraction between planets. And that's the type of thing that I think the electric universe people will admit they need. They need more mathematics interjected into their theories.
Well, I guess maybe I wouldn't push back on that, but I would maybe argue and maybe reword that. I think they need to have more of I think part of it has to do with not having a physical model for the electric field. I mean,
I can't answer that for them.
Yeah, right. I mean, that would just be my
like I said, as with most everything, even with electric universe, I'm on the fence. It has some of its aspects are very appealing. Some of them are a little harder to digest. I mean, the idea that Saturn was once a sun and the alignment, and I mean the mythological aspects of it are are somewhat separate from some of the more physical aspects, but they're very interesting.
Yeah, they are interesting.
But they have some. I mean, there's obviously some support from historical, archaeological records, etc., depending on how you want to interpret it.
Right, right, right. No, I appreciate it. So, in summary, basically what you did again was to take this specific instance. Is it possible, with just at the atomic level, with the distortion of an orbit, or I would say you can even just call it the charge inside, atoms, that this force could come up with a force that is plausible to be what we would call gravity. Is that
Yeah,
correct?
yeah.
And so, and the end conclusion is yes or no. Is that plausible?
The formation of a dipole is plausible.
Okay.
That was pretty much all I was trying to show.
Yeah. Yeah. Okay. Okay. All right. Now we have some people in the green room. That means people have been waiting here. If you want to join us and talk, especially if you're an Electric Universe person and want to answer some of these questions, like the distance question, what happens when you have more than one together, etc. We are open to that. And of course, we have to understand that Ray is not an expert in the electric universe gravitational theory. He was just there to look at its plausibility. So we're not going to be able to answer any questions as I'm throwing at him. And he said, yep, Walt Thornhill or somebody in the electrical universe who thinks more about this would give people answers. So, anybody there in the green room? I also see people in the chat, so we can start taking a look at some of those comments in the chat. But I see Toby, Dennis, Allen, Ian Cohen, Bob Gray. If you, again, are interested in coming up and chatting or making any comments, that would be great. So put your thumbs up or, wave to me in the green room if you're interested in participating. So I do see we have some people out there that I do know. Here's a person we know, Fractal Woman. I came to one of our conferences. That's Lori Gardee. And if you haven't checked out her channel, she's got over 4,000 subscribers. She talks a lot about this stuff. So welcome, Lori. It's great to have you part here. The laws of physics are scalable, in my opinion. Birkeland currents, for example, are scalable. So yeah, she calls herself the Fractal Woman, and actually person who is into fractals will understand the idea of we observe the universe in this sort of the range in which we see it. There are things much smaller and things much bigger, but the universe at different levels is going to look differently, and some things are scalable and some not. So I wanted to welcome her. I also saw, I just want to say, I don't know what else he said, but Jack Kirkendall is here. He'll be presenting next week. And so I'm going to be looking through these comments. And again, if you're in the green room, wave to me and I will put you up there. And if you're not in the green room, please, you can get into the green room. We have 10 spaces available to come online and talk with us. You don't have to have your camera. You can just have audio, and you can go to our subdomain, not www. In place of www, you put live.naturalphilosophy.org, and you will be here in the green room, and you can come up and make whatever comments you would like or discuss with us live. Let's see here. I have also, let's take a look at these comments. So we have a person, well, this is a question more for myself. I saw one here on I need to get another person who is like my production person who looks at these things now that we were getting, more and more people. But I'm going to go back through and see if, yeah, okay. This is an interesting question just in general. This is not for you, obviously. None of these are for you unless they're directly on about your work. It says, for there to be attraction, things have to be oppositely charged. How does a process create a positively charged Earth and negative charged moon? These are great questions, and it's very interesting to ask these questions. But again, in my opinion, you got to end up coming down to what these things are. What is charge in the end? and what does it mean to be to be an Earth and to have it positively or negatively charged? How does that work? And if you have a model that does that, then you can answer those questions. If you don't, it gets to be tough to do that. So, and there are models that do that. I know our model does, in fact, would be able to answer these questions because we have a model for a, electric field, all those kinds of things, a physical one. So again, it all depends on what model you are looking at. Let's see if we have some other questions out here. Anybody waving in the green room? Nope. All right. Where is, if I see, it says, oh, I have Ian. So I'll bring Ian up here. Ian, how are you?
Very well, thank you, David. Yes, thanks for the invitation. I thought it'd come up. Just a general statement, which perhaps Ray won't be in a position to give a definitive answer to, but the theory, this sort of electric universe theory of gravity is plausible to some extent, but I always have the same question with regard to these sort of theories as I do with regard to theories like particle models of pushing of gravity, that they seem to rely upon a conception of a differential force due to almost like a statistical type of environment where you have dipoles, in this case, acting in a particular way. And if this were so, one would think that the force of gravity would be slightly variable. And yet for a particular mass, it seems to be very, very constant. If you have two masses, you can calculate the gravitational force between them, and it doesn't seem to vary at all. So I'm just wondering how that can be squared with this sort of conception.
Isn't there some belief that this isn't, I know people have done presentations on variation in the gravitational constant itself. Now, I don't know if that's just dealing with variation over long periods of time or more on short-term variation, but if the people who support the idea that the gravitational constant can vary, that might be one avenue along which you're pursuing. That might be an answer. I'm sad I can't defend that idea about the a variable gravitational constant, but I know there are people who support that.
I've seen some arguments about the secular variation of that constant, but I think maybe David's father has something on that, and if he's talking about a short-term variation or something which is longer term.
Yeah, I mean, it comes down to this again. I hate to keep hitting the same key on the piano, but it has to come down to what your model is. And so if you look at a model of the universe of if you have a model of, magnetism, electric forces, gravitational forces, and electric and light, if you have a model for all of those, what you can then do is to say, okay, what does happen? For instance, when you make the statement of, okay, a mass, it doesn't seem to vary because of mass, but what's that mass made out of? And what I would say to that, like even in our model, there's too many things that are changing, because again, if you have in our model, we have literally from the nucleon and the orbiting particles around the atom all the way up, and for light, gravity, and everything, we pretty much include everything. You're going to say, well, look, you can come up with a situation where you could be measuring what we say is a gravitational field, and it looks different even though you were assuming that masses were the same, but it depends on density, how the molecular structure is. If you have a particle model where gravity can go through, the gravitational force goes through something like mass, then you have to understand that, well, if that's the case and it goes through mass, but it doesn't make it all the way through, what's the relationship between a gravitational field and the mass? So again, to answer your question, if you put it in isolation, which is one of our great problems in physics, for instance, Einstein throws away the entire universe, right? And he says, you're in an elevator and you're moving down and you're floating in that elevator. And he says, well, are you in an elevator that's moving very quickly down toward the Earth's surface, or are you in space? Well, the funny thing is that he's taken everything away from it, right? It's our tendency is, and I think what's been one of the downfalls of physics, and again, this is my own opinion, is our tendency, and I did a video on this, our thought experiments, we throw all these things out and try to isolate it, just like, for instance, Ray isolated in the electric universe, it isolated everything to 3 atoms. Then the question, of course, you get these questions of like, okay, if you're doing that, if I put lots more, that vector that I saw for gravity, which direction is it going? Okay, and not only that, how does this get at a great distance? If Coulomb's law only is going to be just so ineffective, how could a moon how could this, what they call gravitational attraction or force between the atoms, how can that go distances of light years, which it does, very long distances. So again, I think one of the problems and the answers come is if you have a model for all of these things, you're going to get an idea of how to explain it or even how to predict it. But I think when we say that there's mass, here's a mass, and then gravitational field has to be constant or it looks constant, well, you have even your measuring instrument makes a difference, right? I mean, you're measuring gravity, a gravitational field, any certain way. So again, I think even in the electric universe, my questions always come back to, okay, if you have this and you have these things in isolation, how do they fit in the bigger field? It could be, and like you said, Ray, maybe the electric universe hasn't gone that far in their proposals yet, right? I don't know. Maybe somebody in the electric universe can ask. But again, I think what I would say from our point of view, my dad's looked at the constant G, which was your question, Ian, is that it isn't a constant. Constants don't exist in the universe, in our opinion, many people's opinion. They're just used in our equations where we pin down something where we have to, right? A second, right? We have to define some type of time interval. We have to define some type of weight interval. But even how you measure that is going to be, for instance, measuring the weight in our model, measuring the weight of an electron, what people call an electron, doesn't make sense because it's not, in our model, the electron or that particle is part of the gravitational field. So how can you measure a particle that's part of what we call the part of the gravitational field in pounds, because it's part of the field which you use to measure the weight of things. So again, I guess the answer to that again is you have to have a model for these things in order at least to answer those questions. The more isolated you are, in my opinion, the further off you're going to be, I think, from reality. But I don't know.
But just like apart from the very possible variation of these constants, so-called constant, like the gravitational constant, the mass seems to be the important parameter.
Yeah.
And yet one might imagine, it doesn't depend on the geometry of the object. One might imagine that if you had sort of like sharp edges, like a cube or something like that, you would get a different gravitational force to one with a smooth spherical, but you don't. I mean,
whoa, wait, you do. And what happens is we do not do it that way because calculations, imagine this, right? There's a model at NASA where they try to keep track of, it used to be 4,000 very important objects in the solar system. And they use Newtonian physics to do that. They don't use relativity, they use Newtonian, right? And can you imagine if they tried to make a model of, for instance, when you have a oblong, for instance, this mass like a potato, right? To give you an example of what you're talking about, if you take a mass, if you look at the Earth and the Moon as a mass, right? You get far enough away from it, right? That you look at that system as a mass. If I send a probe around that, gravity is the gravitational field around the Earth and the Moon is not uniform at all. It's very complicated. So what people do is they put the point masses at the center of things. A really good example of this is a paper that was done by Cameron Ribisol. Remember Cameron, Ray?
Oh yeah.
He did this really great.
continuous communication.
Right. I love that guy. He did this amazing paper. And again, on the internet, it's sort of botched up. I need to find that and keep that in a prominent place. He basically took galaxies, Ian, and he broke them down first into arms, which were rectangles, and then he broke those rectangles into littler pieces and did calculations, because what his claim was, which is right, is that the gravitational field around the galaxy is not uniform. And if you do believe it is, send a probe close to all these stars. It isn't not going to go in a straight line, ever. It's not going to go in a straight line. So that gravitational field of a galaxy is not straight. And guess what? When he did the calculations, he calculated that the star velocity on the edge of galaxies, using a non-uniform mass of a galaxy, matched exactly with the observation. Meaning, the reason people postulate dark matter, I'm not going to even talk about dark energy. Energy is a concept, doesn't exist. But dark matter is because of the speed around which the edge stars on the galaxy go at a different speed. When he did a breakdown of the pieces of what a galaxy are with the arms, it turned out that dark matter is not needed. What's going on, and I even have a second part of this story, what's going on is that there is not a uniform gravitational field around the galaxy. They do that because when they're doing lots of galaxies, the model's horrifically difficult. Here's the second part of that question. A year after he had presented his paper, I saw this article that just, my mind exploded. You know what it was? They found 2 galaxies without dark matter. You know what the shape of those galaxies are? Spherical. So if they're spherical, the reason they say, oh, it doesn't have dark matter, because the stars are behaving according to Kepler. Well, they're behaving according to Kepler because a spherical galaxy has a spherical gravitational field. So what I'm saying is that we know, just by analogy, if a person on the street says, oh, gravity around a plant, anything, if it's like a potato, you've seen those potato asteroids, right? Ian, right? Those asteroids where they sent probes. They know that as they get close to it, there's more gravity on this side than there is on another side. They know that. So it's not uniform.
Well, obviously that is the case, David. I mean, we know that from the solar system where we have sort of elliptical orbits, and we have oblate spheroids and so on. I do take your point with regard to this postulated dark matter. I have a slightly different explanation for that myself. But the point I was making is that if you integrate the net gravitational force between 2 objects, you seem to verify Newton's theory that basically, if you take the center of gravity and you take a mass, a point mass positioned at the center of gravity, it doesn't really matter what the shape of the object is. The net gravitational force between these objects will be constant. Now, I do take your point that obviously because of the varying distances from various points, you will get a non-homogeneous type of field. That is quite true. But that wasn't the point I was making.
Okay,
the point I was basically making is that the net gravitational force seems to depend only on the mass of the object.
Yeah, and if you look at what I call a more complete model, like we have, for instance, the answer to that question is based on the nucleon. The nucleon gets mass. For instance, if you're at this level of the universe, when you're talking about mass at what we call this unicosm where we live, right, where what we call gravitational forces, because again, I won't get too, but that's so when you look at expansion tectonics, for instance, how is it if the Earth is gaining mass, and we have lots of evidence, we have geological evidence that that's happened, we have biological paleontological evidence that's, we even have sand dunes from 50 million years ago or 100 million years ago that have different steepnesses, which indicate gravity was different then. So if it's the case, for instance, that one of the things when we were looking at our model in the beginning, One way we're looking at expansion tectonics, and you have to answer the question, where's the mass coming from? Well, in the beginning, we were looking at what people call the electron. And my dad came to me one day and he goes, no, Dave, that's not really the mass, the real mass of, well, in our universe, our, how do you say, level of the universe, if you believe infinite up and infinite down, that really is the nucleon. The nucleon holds really what the mass is. So when you look at our model, for example, and you're looking at mass of the atomic level at our level, and not the, you know, not levels down below that, not subatomic level, but I mean, sub-subatomic level, then that we would consider that, for instance, in our model to be the nucleon. That is what holds, you know, mass. So, and also, you know, constants, again, the constant G is something that we use. It works very well. The approximation, like you said, works quite well. In fact, it works so well, you don't need dark matter for it, according to, you know, Cameron Rugbisall and my father. You don't need the dark matter. So, yeah, I mean, again, and it was interesting in our model, you can't take a nucleus or an electron and say it's so many kilograms. It's going to be in a different system, and that's harder to understand, but that's a different point.
One last point would be, David, that if you postulate some variation in the gravitational force and so on, and if you accept that it's electric in origin, well, then presumably the electrostatic force would also be dependent upon time over large periods of time. It would vary.
Right. Again, you're right. I mean, if it's the case, for instance, us in our model, electrostatic force is exactly is a gravitic force. It's just it's gravity, but it's at a smaller level with a smaller particle that's much faster and much smaller. So, you know, it's a gravitic force. To us, a gravitic force is just particles going in random directions. It's the most common thing in the universe. Particles going in random directions that are similar. And to us, that creates a gravitic force. So yeah, in our model, for instance, you know, the Coulomb's law is a gravitic force. The difference is it's just not the same particle. It's a smaller particle. It's down further. It'd be like, you know, the same thing. It'd be like the sun is the nucleus and the electron is the Earth, and that the gravitic force there, which would be we would call it Coulomb's law. You know, the equation looks just like a gravitic equation, right? The Coulomb's law looks identical to a gravitic equation. So again, whatever your model is, and that's one of the things that I know in the electric universe is one of the questions I always have is, what is charge? What is that electric force? Because if everything relies on it, you know, what is it? What is it physically? Because it isn't magic. It's got to be something. So that is a question. But very, very stimulating ideas.
Thank you very much.
Thank you very much, Ian. I really do appreciate your comments. In fact, I'm thinking I'm gonna have to make Ian my co-host, because he's always able to listen to these things and get something out of it. But I have some other people in the green room. I see James Keene. Anybody else want to come on board here? Let's see here. Let me see what we have. Positive charge. Oh, this is an interesting one. It says here, Dr. Gerald Pollack points out that water molecules are positively charged yet are attracted to form clouds. Earth is negatively charged, probably our moon yet to be no attraction. Again, the question, first of all, I want to just mention that I need to get Dr. Gerald Pollack on our show. I'm sure he's going to come show. I'm being now I call it a show. No, onto our Saturday morning science chats. If you haven't looked at his work, it's absolutely fantastic. There's a fourth form of water he calls easy water. And if you haven't look up Dr. Gerald Pollack. He was given a Lifetime Achievement Award at the University of Washington. A really great person. I'm going to bring up. You remember Gerald Pollack, right? Ray?
Yeah. He was at the last Chasing MPS conference.
Right. I mean, you saw
He's also spoken at some of the EU conferences too.
Yeah. I mean, his work is absolutely fascinating, isn't it? I mean, I just never thought of it. You know, balancing a coin. If you ever balanced a coin on the top of the meniscus of water, what he's saying is those are actually like sheets of water water molecules that are in a hexagonal form, which is a new form. It is quite amazing. So, anyways, I thought I'd bring you up for that. But again, I guess one of the things, and I'm going to say this again, this is just one of my observations, is that the new models out there, and I know the electric universe, and I'm not including the electric universe, not because it's a good model or a bad model. I'm not here to judge on that. But the new models out there, I know Lori Gardee is here. I think she would agree. Jeff Yee, also Glenn Borkert, ourselves, my father and I, charge and positive, negative, and these forces, Coulomb's law, these things have to be explained in a Newtonian way. And that's what all of our new models are striving to do. I know Jeff Yee is that. He doesn't have charge in his models. I know that Lori Gardee, when she's been talking, she seems to be in that same camp. You know, you can put a plus and a minus on something. You can put a positive force on the Earth and a negative on the moon, and you can say that's an attraction. But what is that? I mean, if you have an average person on the street, right, and you're saying, look, I believe in the electric universe, and that's cool, and the world is more electric. You're talking about electric fields, you're talking about charges, and then when a person says, well, yeah, but what is that? What is actually, well, it's the electric field. There's a positive and negative, and negative and positive charge. Why do they come together? Why? And the new models out there can explain that. They can explain magnetic fields. They can explain electric fields. They can explain gravitic fields. And many of them can explain light. And when you have all those things, and you don't need charge, that is, the electron orbits the positron because there's a force there. It's Coulomb's law. Well, we put a positive on the proton and a negative on the electron, and there's Coulomb's law, which happens to look like gravity in the equation form because of the force. And yet you need to explain that today. And the reason I say that is if other models, I name 5 of them, do not have electric fields, do not have charge, and they're explaining the same thing. I think that's where one of the things people don't understand about the new models out there. Oh, they don't explain that. They do. They do explain. So let's see. Here's some questions on gravity. Why Newton, Dave? He was wrong. Gravity is not a constant. No, Newton gave us, in my opinion, gave us a couple absolutely astronomically important things. One, he gave us, talked about force. Force is a concept, right? But he talked about moving masses, and he gave us some mathematical equations for that. And he said that there is a gravitic force, and that gravitic force is something that keeps, makes the apple fall to the ground, and it makes orbits happen. Okay? Now, he never said what that gravitic force was. Lesage talked about it later on. People now give reasons for it. And again, if you claim that electric universe is an electrical force, then again, you get the question, what is an electrical force? What is charge? Otherwise they're just what Alexander Unserker calls arbitrary packages with arbitrary attributes. And one of the reasons I talk about that a lot is because, let's give you an example. If the universe is made of everything, if you're one of those people right now watching this and you say to yourself, the universe is made of one particle, just like, well, that's what particle physics tries to do, right? We had earth, wind, fire, water. That was 4. We then got to the atomic structures, the periodic table. We got it to a couple, 100 and some. Then we said, oh, those things are made of 3 things: protons, neutrons, electrons. A lot of people, even today's mainstream, just say neutrons and electrons, or protons and electrons. And then they said, well, maybe everything's made out of one particle called the quark. The quark quickly got to 9 quarks. And they had all these attributes like upness, downness, colorness. Okay, hold your horses. Hold your horses. If you think that the universe is made of one particle, how does this particle organize itself into the variety we have? Here's the particle right here. I've got it right here. The whole universe is made of these. And what Alexander Unsker says, and one of the things that I like about Borchert's infinity work is, you can answer that question. It isn't the ultimate particle. You'll never find it. But if you do, let's say you do, just logically, okay? Here it is, the whole universe. So I know there are numerous people watching out of the 50, 60 some people watching live right now. You guys, there are people out there that says, yep, I believe the universe ultimately will have one particle, like quarks. Well, the quark people have a real problem because they couldn't describe things with one particle, because there had to be 6 of them. They have all these different attributes, and those attributes are the magical pieces that you have to put together for them to do things. You know, let's just take a simple one, like positive and negative. Okay, everything's made out of these 2 particles. Well, you've got charge, and you've got this, and you've got that. You end up for a one particle, ultimate particle, to organize itself into everything you're seeing right now, everything you're part of now in the universe. It's going to have all kinds of magical properties, because it's going to have to magically organize itself, magically orbit things, magically attract, whatever. So that is one of the problems all models accept. So if your electric universe model, again, and you say charge, it's important. Electric field is the most important. And then I will say, what is that? I want to know physically. I'm tired of concepts. I'm tired of ideas. I'm tired of what we call physics poetry. I want to know exactly what's behind it. And that's what are the new models out there today. They're the ones that I see. And my father and I have a model, right or wrong. I'm not here to push anybody's model, but I'm saying to all of you out there, all of you, that the new models don't need charge. The new models don't need, if they have the electric field, they'll say that they're saying it's all Newtonian. So the answer is, gravity is not a constant. Well, wrong. G is not a constant. G is not a constant. Well, a constant is a mathematical system where we use equations to try to predict motion in the universe. That's where G comes. The idea, for instance, gravitational, one of the things Ian was saying, it's statistical, it's sort of integratable. Well, yeah, in our model, a gravitic field at any level, whether the gravity is made of these really tiny, fast particles at the second level of the universe, fine. It's a bunch of hits. And in fact, gravity, if it's Newtonian, must be a hit onto that. It's a push. It's got to be a collision. And that collision happens, no collisions happen at the same time, but you have collisions. If you believe that it's Newtonian, it's going to have to get itself down to a collision. So anyways, we have people in the green room. People want to raise their hand and come up and make any kinds of comments, talk about electric field. I see people watching. So let me look at, okay, let's look at some other questions, because in general, we're talking about gravity, right? Dissident science. But if you cannot explain everything with math or particles, for example, infinity is not a number you cannot touch. It's just an idea. It's a concept, yeah, for sure. So let's see. But what if you can't not explain everything with math or particles? Well, the claim is you can. Not with math, but with particles or forces. I think if you get away from the idea of forces, they are moving masses, and moving masses hit each other, and you can explain the whole universe. Yeah, that's what we claim, and a lot of people claim. Not only our model, but the new modern models does talk about that. Oh, here's one. Ken Wheeler calls it the cult of bumping particles, LOL. Okay. First of all, it's not a cult. If it were a cult, that means there'd be lots of people following it. And there are not lots of people following it. Now, if you even look at mainstream science, I would just dispute that there's a cult of it, because a cult means there's lots of people of it. And I don't believe that's true at all. In fact, modern mainstream science talks about quantum and, probability. They say that, Newton can't at all describe what's at the subatomic level, even though we have 5 models trying to do so. So, the cult of bumping particles, no, it's not a cult. I would, that means lots of people think it's true, but very few people even think about these kinds of things. So, and the problem is, I think one of the problems is if you subscribe to a model, for instance, you're an etherist, if you, how do you say, throw out someone else's model and say yours is right, be careful, because just like I'm saying, my dad and I have a model. If somebody has an ether model that just is absolutely fantastic and everybody uses, we're wrong. But people aren't humble. I'm really amazed. People, the idea, no offense, but I think when Ken Wheeler's saying that, it's sort of, there's a little bit of arrogance there, because the cult of means I'm going to treat anybody. I could call the electric universe a cult, and a lot of people do. I don't call them a cult. You know why? The electric universe is full of people who are looking to try to describe the universe in a different way because they're unsatisfied with the current model. That's not a cult to me. A cult is when you start believing things and throwing everything out. And I think if you believe that, you actually are going against your own philosophy. So if you use the word cult, I think that's sort of an arrogant kind of thing to say about anybody's stuff. And I know Ken Wheeler does a lot of great work. I like a lot of his work, but I think we have to be careful with that kind of thought. So yeah, see, there you go. Ken is an odd bird, but he's fascinating. He is an odd bird, but hey, odd birds are much more interesting than getting Neil deGrasse Tyson telling us brain teasers, and then when asked if Einstein wrong, just laughs and said he's been proven so many times. It's fact, come on. So, but again, and I'm not here to say that Ken is a bad person or you shouldn't listen. I think he's fascinating. But I think when you make statements like that, I'm not going to, look, I'm in the physics police. I've even got a badge here. Do I have the badge here? I used to have my badge here that I could flash out here and show everyone my physics. Oh yeah, there it is. I am official. There you go. So I am licensed and entitled to come at people when I think they have stepped over their bounds, even if they are really great thinkers and worth. If I would suggest subscribing to Ken, he's a great guy. He tickles my brain in good ways, not like Neil deGrasse Tyson. So. Laugh out loud. That's what he says. Laughing. I'm laughing, Dave. Glad I brought it up. All right. Again, if you're in the green room, please wave if you want to come up, make any comments. And if you want to join us in the green room, you can. And one of the reasons people probably wonder, well, why do I have all these opinions and stuff? And one of the reasons I do, I started listening and hanging around people like Ian and people like Ray and these people back in the early 1990s, in my early 30s. I'm now 61. And I have just met the most brilliant people. I mean, Ken Wheeler is a brilliant thinker. Ian is a brilliant thinker. Jack Kirkendall is a brilliant thinker. I love Ray's work. He's a brilliant thinker. All these people are brilliant. I've been surrounded myself with the people who I consider to be a lot smarter than me. But over the years, I have one thing. My father and I are very much alike. We will not simply accept something because you tell me. If you tell me that the universe is electric, great. I'm going to look at it myself, let it roll around in my head before I make that decision. And through those years, I've come across some things that I just can't dispute, like infinity. It just is a better idea than a finite universe, both up and down and sideways, both up and down sideways, my father says. I like that. So I've collected a lot of things and a lot of ideas. We talk about words. Energy is concept, force is concept. If people talk about the energy in the universe, it's the concept they're talking about. They're not talking about a physical thing. I'm sorry. And a lot of great people I know have come to the same thing. So with those kinds of things, I try to keep people real. So I don't let them talk about we had one, check it out, a couple sessions back, we did one on science poetry. There's a lot of science poets out there. You hear them talk and they use vocabulary, and the vocabulary sounds good and the logic sounds good. But I think what the new models are saying, we're tired. As we say in Portuguese, chega, stop it. Stop it. We want to know what's really going on, with these things. So Oh, here we go. Dissident Science Man reads none of my posts. Rude as hell. Well, I try to read all of them, and some of the posts I don't put up there and won't put up there. So what is your name? Not Ordinary Games. So, hey, why don't you do this, Not Ordinary Games? Why don't you be here with me every Saturday? I'll let you be the person here, and you can help me with that. Instead of me doing all that, I'll take a volunteer area go. There, oh boy, did I turn the tables on that. So, yeah, I mean, I'd love to be able to have somebody, a lot of these shows as they grow, you have to have more than one person. You got to have a person who's just looking at stuff and throwing it on the screen because there's just too much going on there. I've got to run it. I've got to do this. I'm not here to be a martyr or anything like that. But yeah, so Not Ordinary Games. Matthew Cummings, let's see. I'll go back now with Not Ordinary Games and see. I don't see it. Oh, here we go. Dissident Science. What if you cannot explain? Oh, I did. I put this up there. Okay. All right. Anyways. All right. You have been proven wrong. So you're one of the ones I put up there already. So there you go. Not worried about it. Got to let it go. That's ego, folks. Okay. Yep. This is one of the biggest problems in science and in dissident science. In dissident science, people will fall in love with their own theory, and if you don't believe in it, you're wrong. And like I said, that you can do that in peril because our book is written on the shoulders of at least 6 very important people some of them are alive today, and without their work, we wouldn't be making them our model. So somebody could take your idea and make it better, and then you can say, that was my idea. Well, just staying like this is not going to help. Yeah, my suggestion is get your ideas out there, let people go at it. So here's an interesting one, I guess. Ken does not think in charges. Charges are like man and woman. I'm not sure I understand that. So let's keep going and look at some of these. I don't know if I put this up there. Mercury has a greater density than Venus, yet Venus has greater gravity, suggesting mass does not equal gravity. Absolutely, Matthew, it's a very good point, and I agree with you wholeheartedly. And the reason is gravity is a force. It's a force of moving mass of some kind. I personally will not accept the idea it's a force, and it's like Star Wars. It's just a force. That it's got any force in the universe has to be, in my opinion, a moving mass. And yeah, gravity is a moving mass. And yeah, you have nucleons in this, and you're talking about in our level of the universe. You're not talking about the subatomic level of the universe. Then it's mostly nucleons. That's most of the mass that we have in mass. We know that as a fact that the nucleus is the major portion of the mass at our level. And yeah, that mass can be arranged that gravity, if it is also moving mass, a field of small particles, for instance, or whatever it is, or if it's ether and the ether is also particles and they also are caused by collisions, regardless of what that is, absolutely, you can have what we think is a greater density, and yet the gravitational force is different. Well, then that means that gravity and mass interact, and there is some interaction that makes things different. There you go. And I think that is, in my opinion, true. Again, what's your model? Let's say here's somebody here. Let's take a look at this. I believe that the only force in the universe is an electromagnetic force. Hence, I'm interested in the work of gravity, as gravity is most manifestation of EM force. That is a great statement. I know, I think I've actually interacted with this person one-on-one. Again, that's great. But my question to you, Kasim, what is an electromagnetic force? So if it causes everything, then my question is, you still kind of get to the problem of if one thing is responsible for anything and you don't have things below that or above that, then you got the same thing. You have a EM force and it's magical. Again, that's my opinion about that. But all right, let's see. Let's keep going here. Let's see here. Here's another question. Billy Oldman, what do you think of the assumption that all of these particles, like electrons, are identical and interchangeable? Again, a good question. I subscribe to a universe that is impossible to have any two particles the same. It just, if you go through the logic for so many, go through the logic of having a universe and looking at all the forces and all the things that go in it, you end up hopefully questioning about infinity. Is there an ultimate part? Oh, I want to thank you for a super chat. I'm not sure which channel that is on, but I want to thank you. Oh, what is a super chat? Well, let me put that up there. Super chat is actually, you can donate $5 Canadian. Thank you so much. And if you do donate, eventually, as we get bigger, this is our first super chat. That is great. Super chat, you can actually make a donation, and that goes to, we have 2 channels out there where you can make a donation, one to Dissident Science, one to the John Chappell, and a donation goes toward that organization. Of course, YouTube takes a portion, but that's okay. I greatly appreciate it. So if you do put a super chat up there, I will absolutely put you up there and answer questions. How does speed of light up after leaving glass, entering a vacuum, acting on nothing? Where does the energy come from? Very good question, and this has to do with whatever your model for these things are. So Charlie Brown, 76, the answer to your question is, what do you think light is? How do you think light interacts with mass? And if you do, then how does that work? The only one I know of that can answer that question, who has a model for all that, is we do have one. So the way I would say it is that the speed of light, when it is traveling through glass or water, does not go straight through it, because of what people call Coulomb's law, or what we call a gravitic field, gravitic 2 field. That is basically just like gravity. So if you send a space probe through a bunch of suns that are very close, or planets that are very close, that don't explain how they stay in those. I'm just saying, just imagine you place those there, and you place that, it's going to go through on not a straight path. Now, if you're going at the speed of light, which we think is not a constant, but the average speed that we measure is the speed of light, then when it's going through materials, that path becomes even more bent and greater. There's more of an effect on it. Again, that's with what? A light to us is just waves of particles. It's not one particle. It can't be one particle. It's not ether. It's just waves of particles traveling together. So what in our model, the answer would be the path of the light particles, which are in our model the same as gravity, light, electromagnetism, electricity is all the same particle. Those particles will just take longer paths. And once they get out of that, they're going at a straighter path. And so that it's really just a matter of the length of the path. The speed is staying relatively the same. But again, that's one model. And if you have a model and you can explain it, come on here and tell me how your model works and can explain it. But if you don't have a model, it's going to be hard to explain any of that. All right. So I will be ignored. See, there he is again. I guess the person has a lot of attention, wants a lot of attention. There you go. You're not ignored. There you are again. Mass is energy in a different form of energy. Okay, the only thing I would say, Shockwave, is that amongst our most active members, if you find some people who are really true in the mainstream world, you are going to find even people in mainstream science who believe in quarks and the Higgs bosons and quantum, history erasing experiments and the double slit and, things existing in two places at once and all that kind of stuff. They will also say that energy is a concept. And if you don't believe that, just look at the units of energy. There you go. Just take a look at energy, look it up, how many equations we have, how many different units we have. If energy was a thing, it should have sort of, I guess, one designation or whatever. So energy is a concept. Say mass is energy. Maybe at a top level, the way I would say that is inside of mass is moving mass, and you can make, the way I look at energy is a concept physically. In physics, it's not real. You can't give me 3 energies in my hand. But the way we use it linguistically, which I have a master's in linguistics, I work every day with trying to get computers to understand words, so I try to understand words myself. The way I look at people using energy, it's the way it colloquially we use it to say that there's work to be done. I put gasoline in my car and I can get so much work out of it with the machine around it. And so you calculate that energy. But there's a lot of that gasoline that doesn't get used. And, you know, this idea of E equals mc squared, 2, again, if you look at a model like our model, the electrons go around. The reason speed c exists in our model is that whatever is going around the nucleus comes out at the speed of c, and that's where speed comes from. If you want to call that energy, I mean, what does that mean? Unfortunately, E equals mc squared has got a big problem. If you blow up stuff, do you have to blow up the nucleus? And if that's made of parts, then then those parts are made of parts, and those parts are made of parts, then those parts are made of parts. Did Einstein know all the levels of the universe infinitely down, make an integration of them, and come up with this? Yeah. Again, be careful, folks, with the word energy. All right, that's what I would say. Electricity is part of matter and is the way to attract between matter. Again, you have to explain that in some type of physical way. We do in our model explain what electricity is exactly. It's just characteristic, electricity or particles moving in the same direction. But again, I'm not here to push it. I'm just saying you got to come up with not just words. Electric is part of matter. How is that? What matter is made of how? What do you mean by that? I think that's important to know. Hey, we go, Omar. Hey, Omar, I know you are, I connected with you recently, and I think he's doing some pretty interesting work on YouTube. I'm not sure it's in English, and maybe, I'm not sure, remember if he's from India, but I do want to thank you for thanking us for doing this. It's not just me. I'm not the only person. There's a whole organization of people around me, and I just happen to be in front because I have a big mouth, and I think one of the things I feel good about me being in front here is that I do not criticize people. I do not criticize people because I don't personally believe in ether. I don't think you're a bad person. You're stupid because you have an ether model. I'm a person that thinks that every person who sits out there, and all you people who are watching, you are thinking about the universe in a critical way. You are here against everything that you learned in school because you're not supposed to be in a place where you can say the Big Bang's wrong. You're supposed to be in a place where you can say the universe is more electrical than it is Newtonian gravity. You're not allowed to say that relativity is wrong. You're not allowed to say that the Big Bang's wrong. I'm probably repeating myself. You're not allowed to say that plate tectonics isn't a good model, that expansion tectonics, and the Earth's expanding. And not only is it expanding, it's gaining mass. I mean, we have to make sure we support each other. We support critical thinking. The way I look at it is this. I've made this analogy before. If I'm a professor at a university, or even I'm a teacher in a grade school, and I'm teaching 5th grade, and a student comes to me and says, teacher David, Professor David, I think the Earth is flat. I go, okay. Why don't you investigate it? Why don't you take a look and look at it for yourself? I won't go, oh, son, the Earth isn't flat. Everyone knows it is. I don't want you to be embarrassed. What a terrible thing to say to a kid. And if you look at everybody here, one of the things we all seem to have is the ability to say, no, you can tell me what you want. Tell me. I'll listen. But I'm going to look at it. I'm going to roll it around in my own head, and I'm going to make a decision. My father and I are going to come out with a book. We're extending Newton's Principia. We're saying that the entire universe can be explained and hacked with this model. It's just moving mass. A lot of people say that the universe is moving mass. Jack Kirkendall says that. But I'm going to put it out there. Am I going to tell you you're all wrong, this is right, and my father and I am right? No. It's got to be 100 times a day that I think what my father is doing is a bunch of baloney. But we think there's enough merit to it, just like you guys think there's enough merit to doing what you guys do, that merit that you will continue to work. And that's what this channel is about. When you see dissonant people going at it and calling each other names, I know there's a person today in the chat. I've talked with them person online, and it gets into this degrading name calling and not listening, plugging your ears. I'm right, you're wrong. That's the dissident, supposedly a dissident, a person who has a lot of interesting things to say. It's not a good attitude. It's just like, unless you have immense talent, unless you have unless you have the model that the entire human race is following and says this is amazing, then you can be arrogant and egotistical. But until then, why do that? You're just going to turn people off. People are just not going to care about it. They're going to hear that more than they hear what you're trying to say. So, Omar, I know, again, is doing some really great work. And if you are doing great work, and I'm getting more and more people coming my way, send me a message. I've got several people who said, I want to be on your illustrious channel. It's not even a channel program, but it really, we give people a chance. I'm not going to put everything on here. I will not. I mean, one of the things is I want to make sure people aren't just talking about words. I don't get into just part of physics poetry. You got to have more than physics poetry, and that's really important. Here's one. I always watch here because the channel comes up first. Besides, I'm shy and I don't want to be in the hot seat and speak with your group. I don't have anything much to say. I have no credentials. Have a good day. Thanks, Dave. I know Richard Jesh. He's a really great mind. He's a really good person. We have so many great people. That's why I was so sad to see. Man, that's so hard. We've lost so many great people. Oh man, I can just list dozens and dozens of great people. But we have great people here today, and that's what's the most important. And really great. Let's see. Here we go. Does tired matter moves in the same direction to you? Does tired matter? I'm not sure I understand that. I know that some people's, it's not their first language. I'm trying to understand it, and that's okay to me because you don't speak perfect English. Not even people who are perfect English are. Oh, look, thank you very much. Ordinary, thank you. David, don't get me wrong. I'm simply not added to stream. Okay, I see. But thank you again for the super chat. This money, all these funds go toward our organization. So I've got my own job, and most people do, but that's great. And if you put a super chat, you will definitely be. I can't believe it. Today we're getting super chats. Yay, we are moving up in the world, and thank all of you. So let's get ourselves out of here. We're getting close to the end of our 2 hours. And I do thank you again for your support. And you can do that if you're a person who really enjoys the channel. I never thought I was going to say this. We have our super chat on YouTube, and in YouTube, that means you can put a couple dollars in there, $10. People put some, money. All of it goes to the organization. It goes into the bank account of the organization, the CMPS, and that helps pay for doing these kinds of things and makes this all possible. So I do want to thank everybody. So let's go out with a couple of videos, tell you more about what our organization is all about, and get ourselves out of here. Hey, we are the John Chappell Natural Philosophy Society, and I'm also David D. Hilscher, this Dissident Science. I used to make these videos, a lot of them that took weeks to make because I would put my script together and put those graphics in. I hope to someday to get back to that. I really like to put together some really nice, but if you haven't visited, check us out. We're online. If you just happen to bop in here, you can check out both of our YouTube channels, and it's easy to get to. You can go to youtube.naturalphilosophy.org. We'll point you right to our John Chappell Natural Philosophy Society's YouTube page. Click on the like button, subscribe, hit the little bell. When you hit the little bell, you will be alerted as to when we go live, and you don't want to miss that. Also, my Dissident Science YouTube channel. If you want to go check out my videos, I've been on there since 2017, and you can check out a lot of different topics that I've talked about over the last 3 or 4 years. It's coming up in May. It's going to be 4 years. So please do that. And of course, again, you can donate by going to our actual websites. Let's put that up there. Let's see, the John Chappell Natural Philosophy Society has our websites. And where are they? Come on, put them up there, Dave. Here we go. Sorry. Go to naturalphilosophy.org. You can join in the conversations there. It's got, we use Buddy Boss, which is really cool. So if you have a certain area you like to talk about or whatever, and plus, if you have some great work that you've been working on and you want to present it, you don't have to even present it live. You can do what a lot of people are doing. They can record that so you can have control of that. So, you know, some people are good at talking live. Some people, you know, need to have that put together ahead of time. We'd love to hear from you. So I want to thank everybody. And as I always say, oh, wait a minute. Got another stinger for you before we go out. Remember, I'm David D. Hilster. I am, stay critical, stay thinking. I'm Dave D. Hilster, your science therapist, trying to get to the promised land of becoming a critical thinker. No, we don't tell you what to think. We don't tell what truth is, but we allow people who are on the cutting edge to tell you about that in physics and cosmology. Ciao for now.